Thank you, Marcus. Thank you, everybody, for coming. How many other people out here don't know much about acceptance testing on iOS or in general? All right, good. Okay. Acceptance testing, it's an interesting topic. But it does come with a lot of questions. And acceptance testing is a really important part of agile development. And it's also a very, very important part of testing. You need to have acceptance testing for your software. But I think it's really misunderstood often how you implement that, and you have lots of questions like that around it. So hopefully today we'll answer some of these questions and show you how you could implement this. So this talk is going to come in 3 parts. First of all, we're going to talk about the problem of specifying software requirements, doing that well enough that we can actually produce software which actually is what was intended. We're going to look at an approach of acceptance test-driven development. We know about TDD, but this is an approach based on using acceptance tests as a way to drive the development, so you end up with that product that we intended to build, and we'll look at that. And then at the end, I'm going to try and code with you an implementation of acceptance testing on iOS and show you how kind of we're going to take a project which is using some other forms of testing and convert them to some of the other tools. Some different tools, and thank you. We'll try that out and see how that goes so we can give you a demo of how easy it can be. And essentially, the whole point of this talk is to say, is it possible in a mobile application or other software to answer a question about whether you can ship the software not in hours or days, but in minutes? And I'm going to see if that's possible. I think it is. I'm going to try and illustrate the problem of specification of requirements with this made-up project. This is project or feature Fluffy Bunny. You probably all have encountered such projects in your time. This is the vision that the CEO has, and he's given his company the goal of producing Fluffy Bunny. It's going to be the next big thing. It's going to be what is going to turn this company around. Customers are going to love it. All you've got to do is figure out how to build it. So we go away, and the team is set up, and we've got the green light, we've got the budget, and off we go. A lot of conversations take place, a lot of talk about what is Fluffy Bunny? What is it? What do you want us to make? What do we tell the computer to do that actually delivers this thing? So we go away, the deadlines, the clock's ticking, people want to see some stuff, so we get on with it. And what we show them after a couple of weeks of development is this. Right? Initially, we're all really excited about this, but there's a couple of looks in the room when we first demoed this, and then the feedback comes back, and there's a lot of things. QA look at it, the boss looks at it. There's just a lot of question marks about this thing. It's not what really is what the business wanted or what the customer wanted. And the question that we're trying to answer today is, why does this happen, and how can we fix this? And it all really comes down to the fact that there was insufficient detail at the initial stages for us to be able to build the right thing early. This is an important thing, so I'm going to talk a little bit more about this thing about detail. I'm trying to illustrate it with a chart. On this chart, we have on the left the detail that you require to implement a piece of software by role. And on the far left, we've got our boss. And on the far right, we've got our user. And the boss, the level of detail that he can sort of offer to this project is quite low. He's got a big vision. He knows fundamentally what the user wants to do, but he's got a ton of other things to do. He doesn't have the time to come and figure out every single last detail. That's why he hires us to figure that stuff out for him. And if we look at the role of developers or the team on this to have to build it, the level of detail they require is much higher because we've got to work with software and we have to tell the software absolutely everything to be the features or the product that we want. And so the issue comes in where you have the gap between communicating initially that idea all the way up to the amount of detail we need to provide to make the software work. But to help us do that, we normally have either BAs or product owners, whatever. These are the people who help us bridge that gap. The level of expertise or detail they should be able to offer us to be able to tell us what we need to build would be about the same amount of detail we need to give to the computers or the software to write it. But sometimes mobile software or software in general is complex, and the businesses are complex. And so having all those requisite skills to be able to do both those tasks is a very difficult job to do, and often aren't given or provided enough support to be able to do that well. So we continue with this gap, and that gap is where we introduce assumptions or we just make decisions about what we think this thing should be, which ends up with things which aren't quite what was expected, which ends up in more work, and so the cycle goes on. Now, this is one of the common ways in which software is specified. The wireframe that is written by the UX guys as a result of discussions that they may have with the business analysts and stuff. But wireframes, interestingly, work at the level at which the boss kind of wants to think about it, or the user thinks about it. It's what it looks like, and it's how you transition through a journey. But a wireframe like this is insufficiently detailed to tell us all the other things that we need to know about what the software is, which is why we end up with surprises later. No amount of kind of notes or arrows and diagrams can really give us all the details that we need. And so again, if we use this as our basis for the work we're doing, there's not enough there. We're going to have to make some of it up as we go along, which isn't ideal. The other question about this is, if that's the specification that we're working from, or something like it, how do you test that? It's a bunch of diagrams and pictures. Somebody at some point has to figure out, is the work that we've done matching this? So there's still room for even further interpretation as we go from that to a bunch of tests which tell us that's what we wanted. So now there are attempts to test this. And in mobile, we do it with a whole bunch of different tools to try and help us to test this stuff. On iOS, this is a list of some of the things which have been, or tooling which is out there, which is all for acceptance testing. Now, the fact that there's so many of them, some of them long since abandoned, some of them don't work that great, is a sign that this thing, well, it's basically a mess. Right? All these tools trying to do a thing, and the reason I think there's so many of them and so many of them abandoned and moved on from is because the approach to this is just flawed. These tools try to do this all in a particular way which really doesn't work out that well. The characteristics of all these tools are that they are user interface centric, they are derived from wireframes, and they're normally written after development by QA as a separate task. And this is not great, because what this leads to is that it doesn't scale because it's slow and fragile and complex, because it relies upon the user interface to test everything. To keep it maintained when it breaks, because the UI changes all the time. Your UX guys are always making changes to that wireframe they gave you, which means you've got to keep going back and maintaining this. If we don't get to that work because it's lower priority than new work like new features, well, it never gets implemented. And possibly the worst bit of all this is that businesses don't write or read them, or the business people don't. They leave that as a role to QA or programmers to do. So they don't know really what the thing's being tested against. And if you can see it, the last point about this is that the worst aspect of all this is that because of all these things, we tend to abandon this approach and revert to manual testing, which is why we have large teams of QA in a lot of mobile projects who then take manual steps to verify the behavior of the software. And this, as the project goes on and on and on and becomes ever more complex, becomes ever longer and longer. So we are no longer able to say, does this software do what we think it does to the requirements we specified? That then takes sometimes weeks to answer that question, which is not ideal. We'd like to be able to answer that question much more quickly. This makes me depressed. I feel like this guy. You know, it is just, it's like conventional wisdom says, this is just how it is. It's mobile, it's UI, there's no other tools to do this. This is just how it's got to be. We basically go down this path and we end up manually testing everything, which is not a fun place to be at all. So today, the second part of the talk is I'd like to introduce an alternative way of doing this, which I think is far better and, well, doesn't make me feel like that guy. So this is based on the idea of acceptance test-driven development, this approach. A summary of what acceptance test-driven development is basically that. And it's a little bit like test-driven development, which I'm sure all of you are familiar with. But it's at the level of not is the code right, but have you written the right code? That's the way to think about this. So by defining what the work is we're going to do through acceptance criteria that can be executed against the code, you know exactly what to build, and exactly what we're building is what was asked for. There's much less room for kind of making it up, guessing, or making assumptions without the involvement of the people who really understand the business and what we're trying to make, which are the kind of business analysts and the QA guys. Now, to be able to do this, you need a place to write these tests and where to put them. You need a language to describe them in, which is at a level of detail which everybody across the team can understand, so both business guys, developers, and it also needs to be executable. Like, this stuff needs to actually run against the actual software so you can automate it, so you can run it whenever you need to check the behavior. Now, fortunately, it turns out that this tool has been sitting under our noses the whole time. We just haven't been fully aware of it. And the tool that I'm going to sort of show you today is the culmination of work by these people, some very well-known people in our industry. You'll know the last two probably, but the other guy, Ward Cunningham, inventor of the wiki, but also the inventor of this concept called FIT, which is called the Framework for Integrated Testing. And he built that idea up from some work that this guy, David Parnas, did even before then, when he was working on fighter jets and all kinds of stuff. And he's trying to figure out how to describe the requirements of this stuff and how you could do that. And the culmination of all that is a tool called FitNesse. FitNesse is something I'm sure many of you have heard about. We're going to show you how we could use it on mobile today. It is a fully integrated standalone wiki and acceptance testing framework. Let's talk about what that really means. It is a place to read, write, and execute the requirements. And it works with everything. So you can use it for your iOS apps, your Android apps, Java, Ruby, whatever you want. So before I give you a demo of how you could use FitNesse to take a project from using automated testing or automated UI testing to a different one, I want to talk a little bit about how it works so that we've got a sort of something in our mind about what we're doing. Now, FitNesse is a Java file, and it runs, and this is where you put all your acceptance criteria in there. This is where your BAs, together your QAs and your developers, write the stuff and put it in that. And you access FitNesse by a web browser if you like. So that means you can host it somewhere, put it on a server, everybody can see it, everybody can use it. Alternatively, you can also just access it with a terminal and run these things from a command line. So that means it's great for integration with build systems because they can just talk to it too. So how does FitNesse then talk to your software? This is where it gets fun. What you do is you create a special flavor of your application which is embedded within it, something called the SLIM server. SLIM is the protocol to which FitNesse talks to. And what it does is it sends instructions in to that. And what that then does is takes those instructions and passes them to code in your application. It's a very thin layer of code which then passes these messages on as inputs or calls to your system, the system being where you've put all your business logic and all the behaviors and everything that represents the feature or the platform or the app we're building. And out of that system comes messages. They go back through the fixtures, it passes them out and gives them back to FitNesse. And FitNesse then looks at those results compared to what it gave in. And based on what we've told it about what our acceptance criteria is, these things either pass and get colored in green, or they fail and they go red. That happens too. Now, to make this work in your application, there's a very important thing you have to do architecturally to make this possible. You have to think about FitNesse like an alternative user interface to your software. It is like going to be the first user interface that you see, a web-based one that allows you to drive your application and see results back just like as if it was a view of your app. But to be able to do that, you need to do all that good stuff, like have clean separation of concerns between your user interfaces and the business logic. You don't want to mix those two things up. You mix that up, you make this way, way harder. So that's our special custom version of the app with this stuff in it instead. And this would be the app that you ship to customers. This is the one where instead of a web browser, we've got a human who's interacting with a device. That device is sending touch events to your views. They're passing them on to your view controller, which are managing those views, talking to your system. System gives answers back. They pass back up the chain to the user. And what you've got to do is you've got to draw that line between those two things so you can easily swap all that out for this instead. And what's great about this is that this drives you to architect a better app because you know you've got to take this stuff out and very importantly decouple all the business concerns from the delivery concerns, which are user interface stuff. So that's the architecture of this. So keep that in mind as we do a little demo of how we would actually do this on an iOS application and see how this works. This is where it gets fun. Okay, I'm just going to grab a seat. Okay. Oh, I didn't show you what we were going to do. We're going to build. Well, oh, I might need help. Do we press the button?
Yeah, try that.
This is cool. This thing is like a USB thing that's beaming my monitor over there.
There should be a software that you need to run on your desktop, I think.
It'll pop up in a sec.
Whilst we're doing that, just read the 3 easy steps. And
Come on. Ah, there we go.
here we go. Click to share.
That one. I think it's trying to.
What's wrong with the cable?
Oh, yeah, there we go. It's trying.
It's connecting, ready to share. Did we hit a button?
Yeah, let's try.
Start sharing. How about that?
Oh, there we go.
Hey. Yay. We're back. Okay, thank you. All right. So the example I want to show you is, well, we've got a really simple game that we've made. It's one you're probably familiar with. It's tic-tac-toe. Really simple game, right? Until I tried to make one. This is my project. It's an iOS application. It has both an iPhone version and or watch version of this. We thought it'd be fun to play this on your watch. Now, we decided that we have lots of unit tests for this, but we decided that some acceptance tests for this would be really good too. Now, how you would normally do this is with user interface automation. Now, some of the tools I talked about before, they've actually all been superseded by a first-party tool. Apple has now introduced recently in Xcode 7 some really amazing UI automation that allows you to do that type of testing. So this is as good as it gets. Like, this is from Apple. They're supporting it. It doesn't get better than this form of automation. So what I've done is I've written 3 of our first acceptance tests, which are, and you do it by recording, and it writes the code and all the kind of rest of it. And I'm checking that, for instance, a diagonal wins if we hit the right in a 2-player game. What I do want to point out, though, is that to make this work and to be able to assert that the game has been won, I have to look at an accessibility element on the screen that describes the current state of the screen. Now, the UI doesn't give the user any feedback in terms of text. It just highlights the line, which we'll see when we play the game. In fact, if I show it to you, it'll probably make more sense. So let's just run this first, show you how the game is played. And that's why we see things like assert that the index of this label is green, because what happens when we play this game is that, let's see if I can remember how to play this. Yeah, okay, that's the feedback the user gets. We light it up green. So we have to assert that that is now green, which is, you couldn't get more coupled to the user interface than detecting whether this thing works by assessing whether it's green or not. And in fact, we can't even check if it's green. What we can do, though, is check that the accessibility label behind that describes this thing as being in green. So that's why we're doing this thing here. Now, this makes for a fun demo, but this is 3 tests. So let's run this suite of 3 tests and see if we can think about if there's anything wrong with this. Okay, up it comes. Off we go. Test number 1. Okay, diagonal wins. Test number 2. Horizontal wins. Test number 3.
Test succeeded.
Hey. What's wrong with that? Apart from the fact it's all coupled to the UI, and we've had to detect whether we win or not through that, what's the other worst thing about that? It takes time, right? That took about 30 seconds. That's 3 tests. It doesn't get better than this. This is Apple putting a ton of engineering to make this possible, and this is as good as it's ever going to get. How many tests like this should we have, right? Like acceptance tests, well, sometimes you might have in the order of like sort of really 100, 200 really to verify any kind of complicated piece of software. And when you have to do it all through that journey like that, it just by magnitudes gets longer and longer and longer. So whilst most of us will start off with projects where we try this out, it doesn't last very long before this becomes abandoned, because it is just a deeply flawed way to attempt to verify behavior of software. So what I'd like to do instead is show you an alternative way using FitNesse to do that. So there's a couple of steps to this, so I got some notes. So help me along the way. So what we're going to do is we're going to convert this project from testing it like this to see if we can get it to test it through FitNesse and see if we can get this to be a little bit faster and a little bit less fragile as well. One thing I wanted to show you was what happens when the requirements change. We get a new story in. So let's go to the interface for this, not that one, this one. And there's a new feature that comes in, a new request, which is that the user can reset the game and play new ones, right? Pretty reasonable request. So we're the developer, and we come along and we go, let's put that button on the screen. So I'm going to go put the button here. Seems like a sensible place to put it. Try and move the right one. Let's put this up at the top. There we go. We've got a button. New game. All right. We wire that up. We build the code. We've got a new game. We can verify that. We can play the game again in the simulator, check that we haven't broken anything. All right. Does it still play? Yes, it seems to. Good. We haven't broken anything. Now, because those tests are so slow, we don't run them very often, right? You'd be lucky if you run them once a night, overnight. So we finish this work, we ship it, we're all good, we move on. Because they're probably in a state of flux or they take too long, maybe they're already being run just before we ship. So if there's anything wrong with what we've just done, we're not going to find out for a while. So let's run those user interface tests again and see what happens. So it is running. Oh, the test failed. Just going to play the second one. You can see it in the background there. That test failed too.
Test failed.
The game works. We didn't break anything, but the tests are broken. And they're broken because user interface testing is inherently fragile. A small change to the user interface, a small change to the flow, the journeys you have to go to get to the features are so fragile and brittle that you will spend all your time trying to keep this thing working. And because this work often gets pushed to the bottom of the list of work to be done, it often doesn't get maintained. And when we start to ignore these tests, and we don't do them anymore. And that's where we end up back at manual testing. So I wanted to show you that there's those two parts of this. It's both slow, and it's also inherently fragile and not to be relied upon. Let's try and do something better. So this is an application that has got nothing else fancy about it just yet. So what I'm going to do, I'm going to create that special version of the application, which is going to be the thing which FitNesse is going to talk to. So I'm going to create a new target, which in iOS is how we sort of specify different versions of the stuff. And I'm going to create an iOS acceptance tests target. Now, this is something when you, that you can get, download, install it, and you'll have this feature as part of Xcode. And we'll call it acceptance tests. Okay. Now, in and of itself, this thing doesn't, I mean, it's an executable application that we can run, but it doesn't, oh, let's try that again. I made the wrong type of target. Let me just do that one again. Ooh. That works. Oh, you're kidding me. What that means is I don't know why that isn't giving me the So let's just try that one more time. Hey, now we have hey, Xcode, thank you. So fingers crossed we can build that. Now, that's okay. I expected this to happen. And if you work with Xcode, you'll be familiar with the quit and restart thing. It works every time. I love the fact Apple put that feature in. It's just so great. It's like, now, what this is telling me is I've built this thing, but it has a dependency that we need to give to the project. It needs some code. It needs that thing we were talking about in that box, if you remember, the Slim server, and then the thing that would talk to our code and do all that stuff. We need some stuff to help us out with that. Now, all this stuff is, like I said, there are versions of this for all kinds of different platforms, including the Mac. So what we need is OC Slim project. So what I'm going to do is going to create a pod file. Pods, CocoaPods, if you're familiar, is a dependency management tool for iOS applications or Mac applications, and it requires that we make a file. So I'm going to just, in this folder, make a pod file. And this, we're going to target acceptance tests do. Dan, tell me if I get this right. And we're going to say, well, what we need is the pod OC Slim project, the thing that's going to do all the magic. And then I think we do end. I'm not very good at Ruby, so this is hopefully will work. Or Vi. Okay. And now we use CocoaPods to install this. So we've got a decent internet connection. I can now just do pod install. And this will go pull down those dependencies and link them into our project and set our target up with everything it's needed for it to start to be something that we can integrate against FitNesse. Sometimes this takes a few moments. Hey, that was pretty quick. So we installed something called OC Slim project, and we also installed something called C Slim, which is that Slim server thing. And the Slim server is just a thing listening on a port, waiting for something FitNesse to talk to it. So now I go back to here. We have to close that project and open instead the workspace, which is this thing here. Okay, and let's again go back to our target, acceptance test, and build again. No compile errors, it's all sorted out. We've got everything we need. In fact, we can actually run this in a simulator. It doesn't do anything just yet because it's just sitting there waiting for somebody to talk to it, but it does run. And it just sits there doing nothing, but it is waiting for something to talk to it. Okay, so the next thing we need to do is we need to put all the code which is going to be required by this special version of our application to work. So I'm going to just add a few files which are needed. So we're definitely going to need the game. Add that in there. We're going to need that thing. Now you could probably figure out a better way of doing this, put it in a framework, link it in, something like that. But for the sake of time, this is the quickest way of doing it. Okay, I think that's everything, but if there's anything missed. So we should be able to build it again. No, we're missing something. Let's get this fella in. Okay, build, compiled. We've got all the necessary code that we need to do this. So the next step is to wire this thing up with FitNesse. Let's have a look at this. In here, as part of linking this stuff in, a script has been generated called launch. Could do some lunch, but instead it's launch FitNesse. Now we run this script that was generated for us. We didn't have to do anything, /launch FitNesse. It's detected that we don't yet have a version of FitNesse locally that we can run against. So it's going to go tell us to just go download that. So we go there. This is FitNesse. You can go download it. To save time, I've already got a version of it here. So what I'm going to do is just put this over here into that folder. And now hopefully when we run it, hey, it's that easy. We have now just installed FitNesse. It's running on our machine. It's all ready to go. In fact, it's already mostly wired up to our application to start talking to it. And I'm going to demonstrate that the simplest way I can think of, which is let's create a test page. Can you all see this okay? Just make it a bit bigger. Make it big. Okay, so I'm going to add, well, what I'm going to do is, this is just a wiki, as I said before, so I can just edit this page. I've got a nice wiki editor here. I'm going to create a new page, so we'll call this tic-tac-toe. We'll make it nice and big, bang one, so we can see it. And I'm going to now go edit that page. Let's just save that. And what I'm going to do is convert this into a test page, which means it should get a new button at the top of it that says test. This wiki page can run as a test via that button. So if I hit test, do you see that? The simulator just popped up. It's now waiting for the simulator to spin up. This may the first time not execute because it's waiting for this thing to get going. That thing takes a while the first time you run it. We'll let it boot up, and let's run it again. Hey. We're now running and executing our iOS application inside a simulator by hitting a test button in FitNesse. What we haven't done is given it any tests to execute, so everything's green and passing. So what we're going to do now is create the acceptance criteria, which we're trying to sort of migrate from the automation, from the UI test that we had before. Now, these have been supplied to us by our game designers who have been thinking long and hard about this game, and they think this is going to be the way it's going to work. They have described the behaviors like this. Initially, for a very simple game, the rules of the game for playing against two humans is that the game message should be player 1 up, player 2 up, player 1 up, player 2 up, as we take alternate turns. That's the first most basic implementation of this. And that is described in this very simple way, as in if you take these turns at these grid references, which they've given us some really handy notes here, which tell us how this grid reference works, then these are the messages that should be being given to the user interface, and we can verify that then. So what I'm going to do, I'm going to take these notes because they're really useful. Edit this. It's a wiki, so we can. So we don't want it to format this stuff. So you have lots of nice formatting tools, so you can make this documentation, really just well, it really can provide the entire documentation for your project because it's kind of that flexible. So let's have a look. This looks nice and formatted now. And we've got some documentation telling us about how these tests work and what they're doing. And the next thing we need is we need the actual tests themselves. So I'm going to take this here. Now, we didn't have FitNesse up and running, so the people designing the game couldn't enter this directly. But once we got it up and running, they'd be able to just input this information directly on it over a server. They wouldn't need to send us Excel files, but for now, we're going to use this to demonstrate that. So I'm going to edit the page first of all, and probably something I should have mentioned is how FitNesse uses these idea of tables to describe inputs and outputs. You give it stuff that it gives to the system, and then you verify what comes out of it via tables. Now, it has a very convenient button just for these kinds of demos where you say, well, I got this from a spreadsheet. It's not quite yet in the correct format to be a table that can be tested. So I hit this button, spreadsheet to FitNesse, and it turns that into the correct thing with all the right things in all the right places and we hit the format button to do that. Now, one last thing I need to do is I need to give this table, well, what it's going to do is let's call this human for the human. This is kind of the name of the test or the acceptance criteria which we are describing by this table. And it's there. And an interesting thing now happens with that table when I hit test. We go from green, which is what we had before, to orange. We are now into the mode of acceptance test-driven development. Our acceptance criteria has been handed to us, and this is now telling us what we need to do next. Because when I scroll down, it's informing us that I couldn't find the class human versus human, which is telling us that we need to do something here. Human versus human maps to the fixture, which is going to be the kind of adapter between this layer and our system. So and here's where the magic happens. We go back to our project. We go back to our acceptance. Oh, I've got several of these. That's going to be confusing because of our little glitch we had. Oh, I wonder which one it is. 2 folders. Well, I guess it's probably the last one because it goes in that order. So let's try that. I'm going to add a file. new file, and you'll be pleased to know we're going to do this in Swift. Swift works, so does Objective-C with FitNesse. You can use either. I'm going to call this human v human, matching that name of the table. .swift. I think it'll do that for us. And I'm going to add it to the acceptance test target. And because I do this a lot, I have a shortcut for this, which is fit class, where we have to give it the name human, be human. And we have to do that again down here. I'm going to build acceptance test again and see if we've managed to progress any further from where we were at. So we still have orange, but the human v human bit has gone green. We've passed our first part of the stage of development. That is telling us that FitNesse has now correctly found the fixture in our code, which we can then start passing these inputs into and start getting outputs from. We have a nice access point into the application. Now, it's telling us the next thing we need to do. That's too big. Set turns not found. So what it's telling us is that this column here is an input. These are the turns that your game needs to take. So let's give it a way to set that on our class. We just need to give it a way. So we'll give a var. So just doing a bit of Swift here. And we're going to call it the same thing, turns. And that is going to be of a string type. Everything from FitNesse comes in as strings, and everything goes back out as strings. That's how it works. You do all the conversion and everything you need to do inside your fixtures. So that's your string there. Do we need to do anything? We could make it optional, or we could just give it an initial value, which will just simplify things a little bit. So we'll make sure we've always got some value there. So again, let's compile that. Let's just check. Let's do the kind of, the TDD style backwards and forwards. Hit test again. Simulated launches. We don't have orange anymore around turns. That means it's setting values. We now have those values in our fixture. These are the assertions, the game message. When no turns have been taken, the game message should be player 1 is up. When he takes a turn, the message should be player 2 is up. So what we need to do is give this information back, but there's something weird about this. It's saying set the game message. Well, we don't want it to set those messages. We want these messages to come out. So the way you do that and tell FitNesse that's what you're trying to do is you put a little question mark after that, and that says, ask the question, what is the game message, which does something different other than setting the value. So we run that test again. It's now requesting, it's not trying to set, it's trying to get the game message back out. So we should be able to solve this again with this var game message equals, and we'll just again put an empty string in for now, so that we hit our first red. Orange. This needs to be an NS string. One slight quirk between Swift and Objective-C in the way FitNesse talks to it. That's better. We have red. We have our first failing acceptance test. Now the job that we had to do is just to pass these acceptance criteria, just like we would be trying to do to pass unit tests. So let's do that. Well, we could do that the simplest way we possibly could, which is just to return player 1 up, but we won't bother going through that. Song and dance, we will just start to implement this thing. Now, currently this thing has nothing to talk to. It's just a class of its own and doesn't know about our game. So what we need to do is to give it an entry point into playing the game, just the same thing that your user interface would be talking to, the same thing. So because it's all nicely decoupled, we can just basically create this instance of a game and start playing it through this fixture. So I'm going to create something called the game context, which is going to be the way we're going to play this game. So we'll create another Swift file, game context. That's going to be part of our acceptance test target. And I don't want to bore you with this, so I have, I think, written this. BDD. No. Class. Okay, so it's going to be a class. It's going to be called game context. It's going to conform to the game view, which is the receiver of outputs from the game itself. And now if I try wrong with this? It doesn't conform to the protocol. So in Swift, that means this class conforms to the protocol of game view, which we go have a look at that. It just has a couple of outputs which can be set back on it, which tell us about the current status of the game. And now if I do my demo context, here we go, the game code. This is my game context. It's really simple. All it does is basically convert the inputs into calls into the game. So we can give it some turns, and it basically, but it's really simple stuff. There's nothing that exciting about it or hard about it. It's probably simpler code than all the code we had to do all the UI testing stuff. And we've written it once, we can use it everywhere. But we're gonna need this game context, so let's, I think I've saved my mistyping declaration. There it is. There's our game context. We are creating with the type of game, human versus human, because these are the tests that we're starting off with for the first version of this app. And game message here, this thing, should now be asking the game context, what is the current message? After we've played the turns, what is the message you're giving from the system? So what we need is some kind of hook. We need to know from FitNesse, when should I execute the game? When do I have all the necessary information to run it? And what it does is it conveniently gives you these necessary hooks at the right time to be able to call and make the right things. So there is a protocol that you can comply to, which is called the Slim Decision Table, and that is the style of table we're using. And that protocol gives us some the hooks that we get from FitNesse to implement. So there's one that's required, which is the one we're going to use, which is execute. So let's implement the execute method. This gets called after all the inputs have been set, so you can basically run your software and then start collecting outputs and giving them back. So in here, what we want to do is probably say game context. I have a method called play, and I want it to do is to play the turns that we got. Now the turns have been already input to us, so that thing should be ready to go, and all we need to do is pass turns into there. The game will have been played at this stage. So the next thing we need to do is, instead of just doing that, let's make this a computed property, which is a convenient thing you can do in Swift. You can turn any var into something which you can compute the property rather than hard coding one in. So in the get method, what we're going to do is we're going to say game context. We're going to ask the game context, what is the game message or the game status? Game status is a type. It represents all the different types that the game can be in, which gets pushed out. So you can have player 1 is up, player 2 up, the computer is up, player 1 wins, player 2 wins, all that kind of stuff. So we're going to have to switch on this. So we'll switch game status. Oops. Case dot player 1 up. They're the first two things we need to do. And if player 1 is up, we return player 1 is up. That's just the way the tests have asked us to check that. And then this one will do player 2 up. So again, it's really simple code. It's all it's doing is converting basically messages in and out. And we'll need a default case for all the other ones that we haven't yet done. And we'll return unimplemented. So we know there's something to do. Does it compile? Yes, it does. And if we've done all that correctly, when we hit test this time, we should see whether our game plays correctly or not. Green. We know our game works. That test, after it took the simulator time to get up and running, I don't know how long it took, but it didn't take very long at all, right? It happened in the blink of an eye. So those three tests, well, we haven't done all the tests yet, but even those ones, they happen instantly. And this can be integrated with your build system so it can run on every single commit or every build that you do, not something you only run once a week or once a month that you then maintain. And because it's completely decoupled from the UI, changes to the UI will not result in this breaking because it's talking to the stuff that doesn't change so often. So, well, we had some other tests. These were fun too. So we've got the game rules here. These were the tests that we had running in automation. In fact, we only had 3 of them working. But let's put the whole lot in. Let's just copy these across from here. Let's edit the page. Let's verify our app does do all the right stuff. We'll take that. We'll convert that into FitNesse. The game designer's obviously been working hard at this. Notes, this is interesting. We don't really want to, this is some commentary about what the test is testing, but FitNesse is great. It allows you to just do things like put a little comment in there, and it will no longer interpret that. It will just ignore it, and we can continue to put notes in our acceptance test to continue to document what it is we're testing. And again, this needs to be wired up to human versus human, the scenario or the test case we've got. Save that. Check it all looks good. And let's see if our game is doing all the right stuff. Question mark. Thank you. So there's a little bit of conversion you've got to do. So obviously the people who are writing this from the level of the business, they can probably understand how to formulate tables and put the inputs and outputs, but they won't know all the intricacies of, I need to put a question mark in here. So that'll be some little bit of collaboration will happen there as you do that and just fix these things up. Let's run it again. Hey. Unimplemented, there's something not quite right. What am I not doing? I think there might be something I need to do there. Let me just check. So I got my game context. We play the turns. But then, what aren't I doing? That one works. This one doesn't work. I don't know. Anyway. Hey? Well, every single table basically instantiates the fixture from new, so you get a new one every time, I think. Oh, say that again. The what?
The wins case.
The wins. That's okay. These. Oh yeah, of course. Thank you. Okay. You know what? I even wrote this down before. I think I've got this demo. There it is. Oh, no, it's just that one. Same thing again. So yeah. So I just need to carry on being driven by the tests, right? So player 2 up, player 1 wins. Let's just do the first one. Player 1 wins. Thank you for spotting that. I had a mind blank there. You should be able to see that works now. Does this game actually play itself correctly? Those ones are working. And let's just check the last one, stalemate. Let's put the last case in. Case. Yep. Let's do them all. I just, conscious of you watching me typing is might be boring, so. But if you can bear with me, that's cool. Appreciate it. Player 2 wins. Player 2 wins. Now, all builds, all compiles. Let's run it again. That is our QA process. Thank you. There was a little clap there at the front. Deserves a clap. Like, we've taken something that would have taken maybe hours to run as this game gets more complicated. Anybody who's tried to write this game will know there are many ways to play this game, more than you'd think. There's a lot of use cases and acceptance tests that you might write for this. To have them all automated for the UI would just be madness. It you wouldn't do it. This can be your QA process, and if you can do it this way, you can actually put a lot of trust and faith in this stuff. And really, I think, get to that point where you can answer that question, this stuff works, we can ship it, because this stuff tells us the behaviors are all there, we haven't broken anything, and the stuff that we've developed, because we specified the requirements quite in a detailed level, supporting our business analysts with our QA and our developers before we actually did any work, we've got a much better chance that we're probably going to do something that's more like what was wanted or required by our business or our customers than if we'd have just left some of that to just our implementations as we went along. So that's FitNesse. There's one very last thing I know time's ticking on, I want to show you, because a question we often get is, and I think, have a look at it in here. In fact, somebody did leave us this interesting question. They said, quick thought, some of the business folks have asked if it's possible to write the criteria like this in a more BDD style. Is this possible? Well, I know a lot of people, and there's a lot of good stuff in business-driven development and using the kind of terminology which is understandable across the board. And so, do you have to give all that up to use FitNesse? The answer is you don't, and it's really quite simple to implement it this way. Let's go see how you would do that. Let's edit this. Where is Demo Monkey? He's here somewhere. There he is. So, he's over here. The thing I need is on the other screen. There we go. All right. So you can write the tests in that manner. So let's write the BDD scenarios. Just drag them in from here. So save that. And what they asked was, can they write it like this? So that's some stuff. Let's just copy and paste that stuff in, just like we did with the other stuff. Edit this page. So you don't really have to worry about that stuff, but though it's basically an interpretation that takes these messages and turns them into something which we can call into our fixtures with. And again, these are going to have to be scripts, I think. And let's use FitNesse to convert them into spreadsheet to FitNesse. Does it do the right thing? No, not that time. We'll just do one of these. I don't want to keep you too long with this. But I just want to show you because I think it's important to know that we don't lose this kind of capability. So there we have something that looks very much like a BDD scenario, right? Given a human versus human game, when the player takes turns and positions over 1, 2, 3, 4, 5, 6, then the game is a stalemate. And all we need to do is to provide a little bit of a bridge between that code and stuff in here. We need a little bit of support to do that. We'll call this file. What was this thing called? I believe it's called the scenario driver. Don't worry too much about this code. It's pretty straightforward stuff. It's just this little thing I've got is in the wrong screen. Doesn't want to move. Doesn't want to come with me. Okay, let's all go over here. Swipe's broken. Oh, I'm trying to get this thing here. How can I do this? This is a long way around to doing it. New document. It all looks so prepared, doesn't it, though? Oh! Swipe up. Oh, here we go. We can go all the way around here. Oh, he doesn't like it. Okay. Maybe try this one more time. Oh, he came with me that time. What? That one works. Okay, this little demo monkey thing is a real hacky bit of software, and it always doesn't work the best. So what I needed was in that, but I'm not going to bore you with it. Trying to fix it, we can do that later. But effectively, you can use that type of description of your tests just as easy with FitNesse as you can. I personally think that stuff gets really wordy, really repetitive real soon, and that this tends to be a much more convenient way to describe a lot more stuff. So I'm not always sold that this is always the best way to do it. Like there's a lot of words there that I think are redundant, but if it helps the people who are really important in this process in terms of the BAs to understand it, then we do that for them, and we can make that possible. So I think we've spent plenty of time on that. I hope that from that you've seen, though, how much better this could be in terms of mobile testing than the typical approach that we have right now. So let's just finish up with a quick summary of what we've seen. UI-based acceptance testing doesn't scale. Every project I've ever been on where we've tried it, it has become abandoned and we've given up on it. But you've got to have acceptance testing. So you have to replace it with something. You can't just leave it. So we need something else because it's an essential part of Agile. And if you can elaborate the requirements early, it really does save time and effort. You get all the details figured out before you even start to do the work, and then you're only doing work based on what was described, which can lead to us finding all the nitty-gritty and all the little things, and we basically move the process of QA from being something we do right at the end after the fact to being a process that we do before development begins, and QA become part of that process of defining the work rather than just at the end verifying what you've done and then finding what's wrong with it, and then creating a whole bunch of new work. And acceptance testing, to answer the question, it can take minutes. It doesn't have to take days or weeks to do it, which I think is a huge bonus and a win for any project that wants to stay healthy and sustainable long term. So that's it. There's a full tutorial on that thing on my blog, which I've written up, so you can try this at home if you want to. And a lot of the material for this, the background for this, comes from some Clean Coder videos, which recently been done. They're on behavior-driven development. They talk about a lot of this stuff. There's 3 hours worth of the stuff there. I highly recommend it. It's great stuff. And one last thing, I'm going to be doing a course at CodeNode, 24th, 25th of May. We're going to be delving into TDD on iOS with some BDD, some of the stuff we've shown today. So if you'd like to, interested in that, then check it out. It's on Eventbrite or it's on my blog. And if you use the discount code 8thLight, I'll give you a really great discount. So hopefully see you there. I rambled on a bit, but if there's time for questions, I'd be happy to take them. Thank you. We have a question at the front.
Does it work fine with asynchronous calls a lot? We've worked on that a lot of network calls.
Yeah, so what is interesting about this is that it's a really good question, and just with testing, unit testing stuff, you have the same issues, right? But because we're working at a layer much closer to the system, it's much more easily possible to substitute data, stub, mock things out. Often what you do with FitNesse is that you create the test data within FitNesse itself, inject that test data into your system, and that be the data which you're testing against. So you're not actually hitting any network, you're not actually going out to any live services. It's much more like unit tests. And because you're close to it, without all that actual application view stuff in the way, it's much more easily done. So to answer the question, what you try and do is remove all that asynchronicity out of it, even if you have to do some special test classes which remove that. That's how you would tackle that problem. Anybody else? You've got another question at the front.
Why do you think sort of wiki-driven development hasn't really been adopted? Because I've been to places where people just been like, there's no way we're ever using this, that's ridiculous. And they're really resistant, they just don't think it's a good idea. Do you think actually like why people don't?
I'm struggling with it. Every time I come across this and I see this, it seems to me, this is such a better way, why wouldn't we do this? But there is definitely a challenge there in sort of changing the conventional thinking, which is you just do it this other way. You use wireframes, whatever, we've talked about it all. That just seems to be the sort of current bias towards that approach. And I think changing that is difficult. And I don't think this approach is for everybody. I think there are a lot of places this wouldn't, it requires quite a lot of open-mindedness to sort of adopting a different approach to this. The current skill sets out there in QA and mobile especially are all built around technologies for automation, UI automation. And so you have some inbuilt kind of resistance or friction to being able to adopt this kind of stuff. But I think in some places where there's an open-minded approach to different ways of doing this, and there's a real desire to build something long-term sustainable that doesn't repeat the mistakes that we see with this kind of mobile testing, that it's possible to present an alternative. I think to answer it, I don't know if your particular circumstances, but to me, most people don't even know that such a thing exists. They just see it all as like, this is how you do it. This isn't even known to people.
Is it possible to sort of take out the aspect of it and just make a bunch of text files on command line run?
Yeah, so to show you how that is, I mean, like, let's show you what FitNesse has been generating behind the scenes. FitNesse root, whoa, look at this. Okay, I'm not having luck today. But FitNesse root, let's have a look at tic-tac-toe. The test that we just wrote, let's open them up in Xcode. They are literally text files like that, right? And so those text files, I mean, you can actually just call FitNesse from the command line and ask it to run the tests without the wiki being involved at all. So that you can keep the wiki just as a place to enter the stuff, or you can just write them as text files if you like directly. But you can certainly then run them from the command line without the need for the wiki bit at all. That may be to answer your question a bit. You can still use it even if it's not something which the business necessarily wants to get involved in, but as developers who still have to have this suite of acceptance tests in QA, maybe you can use this aspect or an element of it. Is that kind of what you would think? Yeah, so a lot of value
I
in it.
think it's a bit of a weird thing to do.
Yeah, yeah, definitely. Because there are systems and tools out there which people are already very familiar with, like Jira, things like that, where they put all this stuff. So, maybe it's a good strategy to try and incrementally introduce parts of it rather than go, right, we're going to move away from all that and we're going to replace it entirely with this new wiki thing over here, which is a hard amount of change to introduce anywhere. Do we have any final questions? Or should we call it that?
Right.
All right.
Thank you.
Thank you.